Yesterday we introduced the idea of gravitational fields. We said that a field, as opposed to a force, is a line of influence that surrounds something. Now, a gravitational field is a line of influence that surrounds specifically a mass. A gravitational field differs from a force in that a field is there no matter what. As long as we have something causing the field, like let's say the Earth or the Moon or the Sun or anything with mass, then we have these lines of influence there, these gravitational field lines that point toward that object, that influence things in the event that something's in that field. Now, a force requires something to experience it. In order to have a field, you need a producer, the Earth, the Sun, the whatever. In order to have a force, you need to have an apple or a baseball or a truck there to experience that field. A force is a push or a pull. You don't have the force if you don't have anything to push or anything to pull. But you do have a field because the field is what's caused by that big thing that's in the middle that's causing it, that's producing it. Does that make sense? Now, if we do have two objects, if we do have the thing that's producing it and experiencing it, then we can find the force that acts between those two using the equation that we learned and that we were quizzed on today, Newton's law of gravitation. F is equal to g m1 m2 over r squared. Now, if we don't have the experiencer, if we don't have anything to experience that field, let's take away that green apple for a second. We just have the producer. Then the best we can do is find the gravitational field strength, which corresponds, by the way, to the acceleration due to gravity, gm over r squared. What would m stand for in that case? Yep.
Mass of the object experiencing the field.
Yeah, I was expecting you to say mass, to be honest, and it is mass, obviously, but you gave me the exact answer that you should have, which is the mass of the object that's causing the field. It's not just any mass. Okay, it's not just any mass, it's the mass of whatever is causing the field. And then r is the distance away from the producer that we're trying to find the field strength. So let's say we want to find the field strength right there. Even if there is nothing there to experience that field, we can use the mass of the Earth, and then we can use the distance away from the center of the Earth to wherever it is that I'm trying to find the field. Now, sorry?
Imagine Earth is spherical.
It doesn't even have to be spherical. Okay, we have to find it to the center of gravity of the Earth, whether it's perfectly spherical or not. Now, there is another equation that we learned as well. G is equal to F over M. This is the gravitational field experienced by something. So this would be, let's say we've got that apple out here. Again, that apple experiences a force, G m1 m2 over r squared. It also experiences a field that's caused by this producer. The Earth causes a field right here. But the apple experiences the field that was caused by the Earth right there. If we have information about the Earth, then we can use that equation, the middle producer equation. If we have information about the experiencer, the apple right here, then we can use this equation. That make sense? Now, you're always going to have a producer. You're always going to have something causing the field. But you don't always have information about that producer. Maybe you're given information about only the apple and nothing about what caused the field. That's okay. As long as you know information about the apple, then you can still use this equation. Even though we know deep down there is something down here that's causing that gravitational field. That make sense? So force, you got to have two objects. And you're not looking for a field, you're looking for the actual push or pull between those two objects. Field, we have two equations. One that relies on information about this thing that causes it. Okay, that doesn't require an experiencer to be there. One, if you have information about this thing, the experiencer, and not about the producer. If you have information about both the producer and the experiencer, and you're looking for the field strength, then which equation should you use? So you could use both, but don't have to.
You could use GM1 and 2 and then GH.
Or you could use either one. And just use whatever you want, right? Whatever's more convenient for you. Okay, if you've got information about both, then I'd probably end up using this one, honestly, just because it's a little bit shorter and less exponents in our numbers, but it doesn't really matter. If you got time, do it both ways, because you're going to get the same answer. That's a nice little check for you to make sure that you've done it right. That doesn't very often happen, though, that we have information about both and that we're able to solve it that way. All right, we had 3 questions for homework last night. on page 218. I know that there were some people that needed to go over question number 3. Any others besides question number 3? Just 3? All right. 3 says the highest satellites orbit Earth at a distance of about 6.6 times the radius of the Earth. And we talked about what that meant yesterday, right? 6.6 times, I think it's 6.38 times 10 to the 6 meters. What would be the gravitational force on a 70 kilogram astronaut at this location? There's a couple of options to do number 3. I'm going to do it the way that's consistent with what I taught you yesterday, and then I'm going to do it the other way, which is a little bit shorter, but it's still okay. Okay, both of these methods are okay here. What do we got here? We got a distance from the Earth of 6.6 times. What's the radius of the Earth? Is it 6.38 times 10 to the 6? Is that right? So that's the radius or the distance that we're dealing with here from the center of the Earth. 6.6 times the radius of the Earth, whatever that number is. We have a mass here of 70 kilograms. Is that the mass of the producer or the experiencer? Is this astronaut causing the field at this point, or is he or she experiencing the field at this point? Right, it's experiencing it. So we're going to make it ME, just so that we can recognize that it's not a producer mass. Do we have a producer mass here? What's causing the field? The Earth is, right? So let's write down that as well. The mass of the Earth is 5.97 times 10 to the 24 kilograms. Let's call that the mass of the producer, actually. It's 5.97 times 10 to the 24 kilograms. We're looking for the gravitational force. Now, do we have more information about the producer or the experiencer here? The Earth or the astronaut?
You know how far away the astronaut is from how happy the astronaut is.
Okay, so we know quite a bit about both, right? The producer and the experiencer. Which equation do you want to use? The producer equation or the experiencer equation? The producer. Okay, let's try that. Hey, bottom line is, guys, as long as you recognize what variables you have, you can't really go wrong with these questions, okay? It's okay to guess the wrong one. You just make sure you put the right variables in the right one. If you guess the wrong one and then you realize, oh, wait, it's not working for me, it's okay. Just go to the other one. You're not going to get a wrong answer by picking the wrong one. So Josh said, let's use the producer equation. If he's wrong, that's okay. We'll try the experiencer equation. The producer equation says GM over R squared. We know what G is. It's 6.67 times 10 to the minus 11. We know what M is. This is the mass of the producer, so we're going to use 5.97 times 10 to the 24. And we know what R is. It's 6.6 times 6.38 times 10 to the 6. And we got to square that. All right, it's good. Okay, we can use this because we have all the data that we need in order to solve for G with the producer equation. Does anybody have that value, by the way? Josh, do you have that? 24598. 2458. Thank you. And that's going to either be in newtons per kilogram or meters per second squared. Bugger?
They want to find gravitational.
Yep, I know. Yep, we're not quite there yet. So we found the field strength, but unfortunately, that's not what we're looking for. We're looking for F. Now, we also have information about the experiencer. So let's try using that equation now. Some of you said, let's try using that equation right from the top. Okay. Josh said, no. Let's use the information about the producer right off the top. Doesn't matter. Hey, he's right. He got something. It's not what we're looking for, but maybe it's going to help us here. Whoops. That's the electric field, not gravitational field. That's next year for you guys. Do we have the value of the gravitational field experienced by this astronaut? Yeah, it's the same as the field that's caused by the Earth. So we know its value, and we know the mass of the astronaut. So let's just rearrange that to solve for F. M is 70 kilograms. G is this value right here. When we do that math, it should work out to be 16 newtons. or 16 newtons. Now, is there a quicker way of doing that? It seems like everybody in this class overlooked something that may have been kind of obvious. In fact, you had a quiz question today that was really the same thing as this. You just didn't recognize it here because we were doing something else yesterday in class. What could you have done, Jason, in order to solve this question and not done it in 2 steps like that?
Well, I don't know if it's right, but it's made of like M1 and M2.
Yeah, if you want to find the force of gravity, then all you have to do is say F is equal to G M1 M2 over R squared. It's exactly the same thing. Remember yesterday I said if you put this together with this, you end up getting F is equal to G M1 M2 over R squared? So basically that's what we've done here, is use that equation. We've just done it in 2 steps without realizing that we use that equation. Jason, did you do that?
I didn't get it.
Okay. If you do it that way, you're still going to get 16 newtons. It doesn't matter. There's 3 ways to do this question, or 2 ways to do this question, I should say. And both of them are equally correct. One takes about 30 seconds longer than the other, but really, who cares? Okay, as long as you're doing it correctly. Is that good? All right, I want to take a look at one more example here today. Page 220, 4.6. What's the mass of a 60 kilogram student on Mars and Earth, and what's the student's weight at the equator on the surface of Mars and of the Earth? Weight, by the way, if you remember, weight is defined as what? Travis? Right, so we're looking for the force of gravity. That's a key thing to recognize, right? Because look at weight, what's weight? If you don't know that it's the same as force of gravity, then it becomes kind of tough here. We've got a mass here. That mass is going to be the mass of what? The producer or the experiencer? 60 kilogram student is producing the field or experiencing the field? What is it? Experiencing the field. So we're going to call that ME for the mass of the experiencer. Now, we're dealing with 2 separate planets, so we've got 2 producers here. We've got Mars, and we've got the Earth. Let's try for question A using the producer equation. Oh, wait a second. I am so overlooking the obvious for question A. What's the mass of a 60 kilogram student on Mars? Tara? 60 kilograms. What's the mass of a 60 kilogram student on Earth? 60 kilograms. What's the mass of a 60 kilogram student anywhere in the universe? 60 kilograms, because mass doesn't change. What's the weight at the equator of these planets? What's the weight? All right. Weight is force of gravity. You got a couple of options here. You can do essentially the same thing we did in the last question. Say, look, we can find the gravitational field strength. Let's do Earth first. We can find the gravitational field strength at that point for Earth, 6.67 times 10 to the minus 11 times the mass, not of the student, because we're using the producer equation. We have to use the mass of the Earth. That's the producer here. Divided by the radius of the Earth squared, since we're looking at the surface. We get a value of G there, newtons per kilogram. It's not what we're looking for. We're looking for force. So then we can turn around and use the experiencer equation to solve for force. This time we're going to use the mass of the experiencer, which is a 60 kilogram student, multiplied by the gravitational field strength, and that's going to give us the force. Does that make sense? That's pretty much what we did in question number 3 for your practice problems, right? We do that again for Mars now. We've done it for Earth, we do it again for Mars. What's our other option, though? Besides what we did in question number 3, what's our other option? Yeah, if we just do F is equal to GM1 M2 over R squared, this combines the producer and the experiencer into one equation. Here we had to separate them. Producer, experiencer. Make sure you keep them straight. Here we didn't have to keep them straight because they were both in the same equation. Both of them give you the same answer. The second way will be, I say, 20 or 30 seconds quicker than the first way, but it's no better, just a tiny bit quicker. Okay? You guys feel okay with that? I'm not going to completely solve this because we did question number 3, and as I say, it's virtually identical to what we see up here. If you have trouble getting the answer, though, it's in the book, then just let me know, and I'll help you out with that. All right, here's your homework. And you've got about a minute and a half to work on this. Might get one question done, maybe. Page 220. We're going to do questions number 1 to 3. I'm going to copy over table 4.1 on page 218. Although, you, by the time I get that copied over, class is probably going to end here. Okay, let's see what you can get done in the next few minutes and then finish up the rest of it for homework, please.